Welcome to a lesson with Dr. Powell. Let's take a look at an example of finding a minimal number of vectors that span a subspace. The subspace that we'll be looking at is a subspace of the codomain of this matrix function thought of under the column interpretation. It's the range. The range is a subspace of the codomain, and the range is simply the span of the column vectors, because these are the images of E1, E2, and E3, and they span all of the range. So we want to determine among these vectors right now that we have that span the range, we want to find a minimum number of them and a minimal collection of them that actually do the job. So of course we can use all of them, but can we use less than all of them and still span the range? And the minimum number is actually equal to the dimension. So if dimension is 2 of the range, that means that this matrix function would have taken all of its domain, which is R3, and squashed it onto a plane. All right. So, but we want specifically to know which of these, not just the dimension number, but we actually want to know which two of these vectors, if it does go into a plane, would be the ones to choose. All right. So let's proceed. The first thing we're going to do is we're going to think about the Smith normal form, but just one part of it. Actually, what we need is what's called reduced row echelon form. This is what's obtained by doing everything we can to get to Smith normal form by only doing row operations, but we won't succeed. We won't be successful. We won't get all the way down, but the closest we can get to Smith normal form by doing row operations is called reduced row echelon form. Okay, so we're just going to do just going to do row operations. All right, so if we do row operations, what it's going to do for us is, this is the matrix A. It's going to give us R of A, where R is like the row operations done to A. It's an isomorphism, preserving dimension and other things. And we're going to take a look at the images of E1, E2, and E3 here. And up here, we're going to get 3 different vectors, which are going to be the spans of these guys, or potentially 3 different vectors. They may not all be different sometimes, but we'll get 3 vectors at least up here, and that come out of this. And so we'll be looking at the range of this, which is spanned by those. And the format that these will be in will be so simple. It'll be so simple to see which ones actually span. And so we can find a minimal spanning set very quickly. And then we just trace it back to A, and we know exactly which ones to choose. That's the basic idea. So let's get started. Let's do just row operations. Well, we already have a 1 in this position, so let's airdrop down. So we airdrop right here, multiplying this top row by -1, and then airdropping it right there on that guy. So we would attain, so you have 1, 0, 1, 0, 1, 1, and then coming down right here, we get a 0. That just stays a 1. And then a -1 and a 2 becomes a 1. Okay, that's just one airdropping. Notice we can't do a column operation to go this way because we said we're only doing row operations. So we've kind of done at least, so basically, if we're doing just row operations, we stop once we have a 1, 0, 0. Okay, so we've done as much as we can with this part of the Smith normal form with just using row operations. We got the 1, 0, 0, and then we move on to the next part. So notice we can't really do much right up here anymore on this side of the 1 if we're using row operations. If we did, actually, we might kind of, yeah, we can't really do much right here, at least at this step. On the next step, we might be able to a little bit. If we can get a 1 right here, which we do, we can actually use this 1 to airdrop up and down, but it's already 0 right here, so there's no point. But if there was something else, we could put a 0 there. But right now there's, it's already 0. So we could go airdrop up and down. But here, let's airdrop down at least. But as we do so, notice this row is the same as this one. So if we airdrop, multiplying this by, so we multiply this by a -1 and then put it right down on there, we're just going to get zeros right there. So we'll have a 1, 0, 1, 0, 1, 1, 0, 0, 0. Okay. So ones to airdrop up and down. Well, that's like the last bit. We can't put any 1 down here to go back up this way with zeros here, so we don't affect these guys. So this is as far as we can go. This is called reduced row echelon form. So reduced row echelon form, basically what it has is the column. So we have some columns, which we with ones, which we'll call pivots. And what we know about these pivots is up and down from the pivot, 1 is 0. And to the left of the pivot, 1 is 0. And every single, and every single row either has if it has a pivot 1, or it's 0, all zeros. So, so what is reduced row echelon form? It's trying to get to Smith normal form, but not exactly. But what we have is every single row. So each row has either a pivot 1 or it's all zeros. A pivot 1, again, is something such that up and down from it are zeros. And to the left of it is zeros. The idea that to the left of it is zeros actually allows you to airdrop up and down to actually make right above it 0 and below it 0, just using row operations. So that's why we can get here as we try to get to Smith normal form, but are unsuccessful perhaps, potentially. And in this case, we actually are unsuccessful. So this is an example of that. We didn't quite make it all the way. All right. But this is where we can now actually figure out what we were after. Which of these vectors right here are enough to span the range? All right. So let's see which of these vectors are enough to span the range. Notice the columns with pivots in them, pivot 1s, that's enough. Because notice that this guy right here is actually a sum of those. I mean, well, this whole column, that is actually like this one plus this one. This one is a linear combination of those. In particular, let's think about what E1, E2, and E3 do. So that's like putting E1, E2, and E3 into this combined map here. They go into A and then into R, and then they come out. So E1 and E2, they go to these guys. E3 goes to this, which is the sum of E1 and E2. In fact, you can see that more readily. You see that E3 is sent up to a sum of E1 plus E2, and these guys are just sent to E2 and E3. So it's E1 and E2 is what I meant to say. E1 and E2. So it's clear to see that E1 and E2 are a spanning set for this range. So isomorphically, we just trace that back to get the spanning set for just the range of A. And so tracing that back, it's going to be the same. So it's going to be the same thing as, so the pre-image of E1 and E2 under R is the same as the image of E1 and E2 under A, which is these guys right here in those positions. Precisely the columns that had pivots are the ones that are enough to span. And in fact, 1, 1, 2 is actually, we can see, is in the span of these. In fact, simply the simple linear combination of 1 times this column plus 1 times this column is that, just as it was here. However, this over here, it's easier to see what the linear combination would be, and then we can pick it out. But in general, we can just remember, it's just the columns that have the pivots in them. if we just do row operations. If we did column operations, we'd mix up where the columns were, so mix up where the inputs were, and we don't want that because we want to know precisely which columns right here in the output of A are the ones we need. Thanks for watching.